Welcome to the lecture series of network theory. We have started learning the application of different network theorems in DC circuits. Today we will learn about the application of Tellegen's theorem in DC circuits. So let's start the class. This theorem states that in any linear or nonlinear, passive or active, time variant or time invariant network, the summation of power, if it is an AC circuit, then instantaneous or complex power for AC sources delivered to all the branches is zero. That means, as per this theorem, the total power delivered by all the energy sources in the network will be equal to the total power absorbed by all the passive elements in the same network. Now let's understand this theorem with a real example. Now, as we can see here in this DC network, we are having four passive elements or four resistors, one current source and one voltage source. That means two energy sources. First, we have to find out the current value that is flowing through every branch or every component in that network. Now, to do that, we can apply any suitable or convenient network analysis method. For this network, I have applied the superposition theorem. Now, as per superposition theorem, first I have considered the current source and I have deactivated the voltage source by sorting that path. Now, in this circuit, what we can see here that we have this 4 ohm and this 4 ohm resistors connected in parallel. So when we will find out the equivalent resistance of this parallel branch, it will be simply half of their each value, that means 2 ohm. And that equivalent resistance will be connected in series with this 2 ohm. That means that the equivalent resistance of that series path will be again 4 ohm. And with that 4 ohm equivalent resistance, again this 4 ohm will be connected in parallel. So now if we find out the equivalent resistance of that parallel path, so the equivalent resistance value will be again 2 ohm. So now if we apply the current division rule here, so the current value which will be flowing through each resistance, they will be, for first 4 ohm resistance, it will be 2 ampere and that will flow in downward direction. Since I have already discussed about the application of superposition theorem in my earlier lecture, and I have applied superposition theorem in other classes when I discussed about or simplified the network by using any other theorem. So I am not discussing superposition theorem here in detail. That is not the scope of this class. So directly I am writing the current values. Now the current through this 2 ohm resistor, because of this current source, will be 2 ampere and that will flow from left to right. Current value through this 4 ohm resistor, this will be 1 ampere and that will flow in downward direction. And current value through this 4 ohm resistor, that value will be 1 ampere and that will also flow downwards. Now these are the current values that are flowing through all these resistors or passive elements, and current value for this current source is already known, is already given. Now in the next step we will deactivate the current source and we will consider the voltage source. So for deactivating the current source, we will simply open that path, and if we do that, then the modified circuit will look like this. Now in this circuit, what we can see here that these two resistors are connected in parallel, so easily we can find out the equivalent resistance, and by applying the concept of KVL in that complete path or loop, we can easily find out the current value in that loop. And from that, again, if we apply the current division rule, then we can find out the individual current value through this resistor. So I am not again going into detail. Now because of this 8-volt voltage source, the current value through this 4 ohm resistor, it will be 1 ampere and that will flow in downward direction. And current value through this 2 ohm resistor, that will be 1 ampere and that will flow towards left. Then current value through this 4 ohm resistor, this will be 0.5 ampere and that will flow upward. Current value through the other 4 ohm resistor, that will be also 0.5 ampere, and that will also flow upward. And since current through this 2 ohm resistor is flowing towards left, that means the current through this voltage source also flow towards left, and that net current value which will flow through this voltage source, that will be also 1 ampere, and that will also flow towards left. So I am also noting that current value here, that the current value through this 8-volt voltage source, that will be also 1 ampere, and that will flow towards left. So that will be equal to the current value with this current value. So by now, by applying superposition theorem, we have already found out what will be the current values through every branch or through every component in that given network. Now our next task is to find out what will be the power delivered by every energy source in that network, and what will be the power absorbed or consumed by every passive element in that network. So here we have redrawn the original circuit, and now for this 4 ohm resistor we have seen, now we are calculating the power value or the power absorbed by the passive elements. So now the net current value through this 4 ohm resistor, that is 2 plus 1, and since both the currents, because of both the energy sources, they were flowing in the same direction, and that was downwards. So here the net current value through this 4 ohm resistor will be 3 ampere, and it will be in this direction. So the power absorbed by this 4 ohm resistor, that will be I square into the resistance value. So here it will be 3 square means 9, and the resistance value is 4. So it will be 36 watt, and we will take the power absorption as positive. So next, the net current value through this 2 ohm resistor, first we will calculate that, and the net current value is, we have seen that 2 ampere current was flowing towards right and 1 ampere current was flowing towards left. So net current value is 1 ampere, and that will flow towards right. So the power absorption by that 2 ohm resistor, it will be I square R. So it will be 1 square into the resistance value. So it will be 2 watt, and that will be also taken as positive. Now the power absorption by this 4 ohm resistor we will calculate, and the net current value flowing through this 4 ohm resistor is also, it will be 1 ampere current which is flowing downwards, and 0.5 ampere current is flowing upwards. So net current value is 0.5 ampere, and that will flow in this direction. So the power absorption because of this 4 ohm resistor will be I square means half square, so 1 by 4 multiplied by the resistance value, which is also 4. So it will be 1 watt, and that will be also positive. And the rest is this resistor. The net current value through that resistor is also 0.5 ampere, and that also flows downward. So power absorbed by that 4 ohm resistor will be I square, again it will be 1 by 4, and the resistance value is 4, so it will be 1 watt. That means total power absorbed because of all these passive elements, it is 36 plus 2, 38, 39, 40 watt. Now we will find out the total power delivered by those energy sources. Now because of this current source, the voltage drop across this current source, first we have to obtain. Now because of this resistor, the voltage across this resistor, the voltage drop will be, it will be the current value which is 3 ampere multiplied by the resistance value. So it will be 12 volt. That means the voltage drop across this 4 ampere current source, it is also 12 volt. So the power delivered by this 4 ampere current source, it will be 4 multiplied by 12, so it will be 48 watt. And the value of this voltage source, voltage value is 8 volt, and the current which is flowing through this 8 volt voltage source, that is, we have seen that that value is 1 ampere, and that current is flowing towards left. but that current value is because of only this 8-volt voltage source. But in the previous step, when we obtained the current value which flows through this resistor because of this current source, since we deactivated that voltage source, so that voltage source was not there in this circuit, but the current value which will be flowing through this path, that will be finally also flowing through this voltage source because of this current source. So we can also write that the current value which will be flowing through this 8-volt voltage source because of this current source, that will be the same current which is flowing through this resistor, means through this series path, and that is 2 ampere, and that flows towards right. That means the net current which flows through this 8-volt voltage source, that is 1 ampere towards right. So here the current value which flows through that 8-volt voltage source, that is 1 ampere towards right. But because of this voltage source, since the positive polarity is at this side, at the left side, and negative at the right side, so only if we consider this voltage source, the current which will be delivered by this voltage source, that will flow towards left. So that current direction will be taken as positive current direction. But since the net current through this 8-volt voltage source is flowing towards right, so with respect to that direction, the current value will be taken as negative current. So that means the power which will be delivered that by that 8-volt voltage source, that will be the voltage value which is 8 multiplied by the current value which is -1. So it will be -8 watt. So the total power absorbed, so the total power delivered by the energy sources in this network, it is 48 minus 8, so it is 40 watt. So here we have seen that the total power absorbed by all the passive elements in that network is 40 watt, and the total power delivered by by all the energy sources, that is also 40 watt. So this is the proof of this Tellegen's theorem. With this I end today's class. See you in the next class. Thank you.